Everybody has heard of the donkey vote. The voter numbers all the candidates on a ballot paper from top to bottom in the order that they appear on the ballot. It is a valid way to vote. After all, it might really be the case that the ballot paper is printed in the order of preference of the voter. But not everybody has heard of Robson Rotation, the system designed to reduce the impact of a large number of donkey voters by changing the order of candidates on each ballot paper that's printed. Hello, I'm Mark Fletcher from the Smart Vote team at the Australian National University, and I'm here to talk about Robson Rotation. First, let's get a better understanding of the donkey vote. Preferential voting systems, as the name suggests, requires the voter to express some kind of preference between candidates. In Australia, this is done through ranking candidates in order of preference. You put the number 1 in the box indicating your first preference, 2 in the box indicating your second preference, and so on and so on. The donkey vote is where the voter numbers all the candidates on a ballot paper in the order that they appear on the ballot, usually top to bottom. It is usually a valid vote. Imagine that this is your ballot paper, and everybody in your electorate is a donkey voter. What is going to happen? Well, obviously, whoever is at the top of the ballot paper is going to win. The candidate listed first on the ballot paper will get 100% of the first preferences. But, of course, not everybody in a real electorate will be a donkey voter. But some are. The donkey vote entry in the Oxford Companion to Australian History claims that 10% of voters are donkey voters. Studies from the 1960s suggested it was about 3%, if not lower. What appears to be uncontroversial is that there is at least some advantage to being at the top of the ballot paper. If you're in a seat with a tight margin, being higher up the ballot paper than your rival could be enough to affect the outcome. Here, Darkholme is gaining the primary benefit of the donkey vote. Let's imagine that the effect is as low as 3%. Here, candidates are sorted by their first preference that weren't donkey vote ballots, and the donkey vote effect is highlighted in blue. You can see that there are situations where even a 3% boost to the first preference vote will mean that the candidate will not be eliminated in the first cut. Darkholme ends up in the second last place instead of the final place, meaning the votes for Frost will be eliminated first instead. Depending on what the second preferences look like, this might be enough to affect the outcome of the election. Importantly, even if Darkholme had been eliminated in the first round, the benefit of the donkey vote then goes to whoever was second on the ballot. The fact that Xavier was second on the ballot might be enough to win the election if the non-donkey vote was close enough. So, what determines the position on the ballot paper? In Australia, it wasn't that long ago that names on the ballot paper were printed in alphabetical order of surname. Good news for the Armours, Armstrongs, Arthurs and Ashleys, but bad news for the Yeomans, Youngs, Yeardleys and Yates. Graham Orr's ballot order donkey voting in Australia details the two changes made in the 1980s to the federal ballot paper. First, political affiliation was introduced. If you know that you liked the Free Beer Party, but didn't know who their local candidate was, now you knew. Second, random order for House of Representatives ballot. If you jumble the order of candidates, having an alphabetically lucky surname now counts for less. Importantly, as Orr notes, randomizing the order on the ballot paper doesn't eliminate positional advantage on the ballot. It merely approximates a fair electoral process by giving each candidate an equal chance of attracting its benefit. But what if instead of having one randomly ordered ballot paper, you instead had lots of randomly ordered ballot papers, and you were given a ballot paper order at random. Assume that you have 100 ballot papers and everybody's a donkey voter. First, how many of those papers will have Darkholme as the first candidate? With 5 candidates, you can expect 1/5 of the randomly ordered ballot papers to have Darkholme first. But note that the same thing happens for all the other candidates. With 100 ballot papers, that means each candidate should have 20 ballots where they are the first named candidate. Assuming everybody is a donkey voter, the spread of first preferences looks like this. So we know that not everybody is a donkey voter. Because the maths is easier to show in this video, let's assume that 5% of voters are donkey voters. All things being equal, what should we expect to see? The donkey vote is now spread out over the candidates. Robson Rotation, this practice of putting a random order of candidates on each ballot, reduces the impact of donkey voting. So now you can see how Robson Rotation works with an ordinary ballot, but the ACT election, which uses Robson Rotation, is far stranger still. But that might be a story for next time. Remember, if you want to know the range of options available to you at the ACT election, check out SmartVote at smartvote.org.au.